find the number of paths from 0, 0 to 4, 6, such that you can only move 1 unit right and 1 unit up on each step. So this is a very similar problem to the previous one. So let's say you had, let's say you wanted to get from this point up to this point. Again, you can only move right and you can only move up. So this problem was very similar to like the example that we just did. So we want to find the number of ways to move from the point 0, 0 to the point 4, 6 by only moving right and up on each step. So the idea is like, notice that like we can consider a string with 4 R's and 6 U's, where each string represents exactly one path on the grid. So again, for example, the string R, 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 like U, 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 R, U or something, this would represent the path 3 times to the right, 5 times up, 1 time to the right, and then 1 time up. So again, this problem is equivalent to finding the number of ways to arrange this string with 4 R's and 6 U's. And yeah, that's basically all. So again, we can create a sequence of like 10 blanks where each blank is either an R or a U. And notice that we have 4 possible R's. So we need to select 4 of these blanks to put an R in. So maybe we select this one, this one, this one, and this one to put an R. And the remaining slots will all be U. So basically, to find the number of strings, we would just need to find 10 choose 4, which is like the number of ways, the number of possible like strings of R's and U's that you can form with exactly 4 R's and 6 U's. So again, we can like calculate it with the combination formula. So 10 choose 4 is equal to 10 factorial, like using the formula, is 10 factorial over 4 factorial times 10 minus 4 factorial. So that's going to equal 10 factorial divided by 4 factorial times 6 factorial. And we can kind of like, to simplify the factorial, the 10 factorial on the top, I can write as 10 times 9 times 8 times 7, then times 6 times 5 times 4 times 3 times 2 times 1, but that's just like 6 factorial. And on the bottom, I have 4 factorial times 6 factorial. So the 6 factorials kind of cancel out. So this would simplify to 10 times 9 times 8 times 7. And the denominator is 4 times 3 times 2 times 1. So this 4 and the 2 cancel with the 8. This 3, 1 factor 3 cancels. So this would give an answer of 210. Yeah, in this case, we chose which positions we put the R in, right? So we did 10 choose 4. Alternatively, you could have also did 10 choose 6. You could have chosen which of the 6 positions you could have put the U's in, right? But that's why this is a very famous combinatorial identity, which is n choose k is equal to n choose n minus k. So just a side note. And the reason for this is like, if you had n objects and you want to choose k of the objects, that's equivalent to choosing n minus k objects and you don't choose. So like, if I had like 10 candy bars and I want to select 3 of the candy bars, that's equivalent to not selecting 7 of the candy bars, which is why like n choose k equals n choose n minus k. So that's kind of like similar to what's going on in this case. We did 10 choose 4, which represents the number of ways to choose 4 of the slots to be an R. And similarly, we could have chosen which of the slots to be a U. That would have been 10 choose 6. And if you were to do 10 choose 6, like you would go through the exact same calculations. Like you do 10 factorial over 6 factorial times 10 minus 6 factorial. And if you were to do the math all over again, like you would find this also equals 210. So it doesn't matter like if you do 10 choose 4 and 10 choose 6, it'll give you the same answer.